All right, in this lesson, we are going to solve quadratic equations by a method called completing the square. And so to start off, we need to talk about the square root property, which says if a squared equals b, then a equals the positive or negative square root of b. For example, if I just tell you a squared equals 25, then a could have been 5 or a could have been negative 5. Because both 5 squared and negative 5 squared would give us a positive 25. So that square root property just basically says that you have the positive and negative square root. Okay, and so we can use that property to solve quadratic equations if we have a perfect square on the left side. So x squared equals 25 means x equals the positive or negative square root of 25, which would be positive or negative 5. Okay, this next one, we first need to isolate the square. And so we get x squared equals 16, which means x equals the positive negative square root of 16, which is positive negative 4. Okay, here we have a perfect square equal to 9. And so this expression is kind of like our a squared. And so that means just the x minus 1 would equal the positive negative square root of 9, which means x minus 1 equals positive negative 3. And so we need to add 1 to both sides. And when we do that, write that in front of the plus or minus, because we have two cases now, 1 plus 3 and then 1 minus 3. And so one answer would be 4, the other would be negative 2. Okay, here once again we need to isolate the squared term. So divide both sides by 5, and we get x squared equals negative 4. Using our square root property, x equals the positive negative square root of negative 4. And we know when we see a negative under the radical, we need to take an I out. And so that means x equals positive negative I square root of 4, which we know is positive negative 2i. Okay, here we need to isolate the square. So first, subtract 3. And then divide by the 4. So x squared equals 3/4. Using our square root property, x equals positive negative square root of 3/4. And whenever you have a fraction, you square root the top and square root the bottom. Okay? And you don't want a square root left in the bottom, but luckily square root of 4 is just 2. And so you would leave your answer as plus or minus square root of 3 over 2. And you can put the plus or minus in the numerator, or it can be completely outside the fraction. Just make sure the 2 is not under the radical. Okay, here to get rid of 1/2, you could technically divide both sides by 1/2, but it's easier to multiply by the reciprocal to get rid of multiplying by a fraction. So we multiply both sides by 2. And then we are ready for our square root property. So x plus 4 equals positive negative 6. And then to move the 4, I like to just write it as the opposite sign on the other side of the equal sign, and then use my cases, negative 4 plus 6 or negative 4 minus 6. So we get 2 and negative 10. Okay, and so anytime you have a plus or minus number inside the square, you're going to end up with two different numbers, whereas if you just have x being squared, that's when you have your plus or minus expression. Okay, and so that's how you use the square root property to solve quadratic equations. And so it turns out we can turn any quadratic equation to have a perfect square. We can rewrite any quadratic equation using this notation. And that process is called completing the square. Okay, and so it's a method in which a quadratic equation is restructured so that one side of the equation is a perfect square in order to use the square root property. Okay, and so to jump to the punchline, we're trying to create a perfect square trinomial. And so if I have x squared plus 8x, if I put a 16 here, this would factor to x plus 4x plus 4. Because 4 times 4 is 16, and 4 plus 4 is 8. So that could be rewritten as x plus 4 squared. Okay, for the x minus 6x, if I put a, let's see, 9 here, this would factor to x minus 3, x minus 3. Because negative 3 times negative 3 is positive 9, but negative 3 plus negative 3 is negative 6. And so I could write this as x minus 3 squared. And so how I'm getting this number, how you get the 16 and how you get the 9, is you take half of this middle number, which would be negative 11, and then square it. And so negative 11 squared is 121. And then this would factor to x minus 11. So whatever half of b is, that's the number that's going here. So for example, half of 8 is 4. And then when we square it, we get the 16. And then the 4 shows up right here. Okay, and so half of 14 is 7. Square the 7 and you would have 49. And so in general, for any real number b, you're going to have half of b divided by 2 and then square it. And then here, you're just going to have whatever half of b is. Okay, so we're going to solve each of these quadratic equations by rewriting it as a perfect square. And so to do that, your setup is you have to have your x squared and your x term equal to a constant. And then I like to add boxes. Okay, and so you're going to add a number to both sides of the equation. You can't just add a number to one side of an equation. You have to keep it balanced. And so the number you're going to add to each side is half of b, which half of b would be 6 over 2, which is 3 squared. 3 squared is 9. And so 9 is what we're adding to each side, half of b squared. Okay, and so that came from 3 squared. Okay, so now this factors to x plus 3 squared, and this simplifies to 25. Now we can do what we were doing at the top and use our square root property, which means x plus 3 equals positive negative 5. Move that 3 to the other side of the equal sign, and then write your cases. Negative 3 plus 5, which is 2, or negative 3 minus 5, which is negative 8. So our answers are 2 and negative 8. Okay. Here, we need to set up and move the constant to the other side. This is the only method where we put the constant on the right side instead of setting it equal to 0. Okay, and so we have 7 minus 32. Which is 25, negative 25. And then this is where I add my boxes. Half of b is negative 3, square it, and we get 9. Okay, And so this factors to x minus 3 squared. Negative 25 plus 9 is negative 16. And then our square root property. This means our answer is going to be imaginary. Square root of negative 16 is 4i. And then we just need to move our 3 to the other side. And we're not going to be able to break it into our cases because this is an imaginary unit. So this would just be our final answer. Okay, and so when the coefficient of the x squared term, our a value, is not 1, you must divide the entire equation by that coefficient before completing the square. So in these next two examples, that's what we're going to have to do. And so here we're already set up with our constant on the other side. And so we just need to divide the entire equation by 2. It's going to leave some fractions, but they actually work out okay. Okay, and so half of b is the same thing as multiplying by 1/2. And so that's going to give me negative 7/4. And then when we square it, you square the top and square the bottom. It's going to give us a 49/16. Okay, and so when I complete the square, I'm going to have a 49/16 on both sides. Okay, and so then this factors, remember it factors to half of b, which was negative 7/4 squared. And then to figure out negative 5/2 plus 49/16, we need a common denominator. So we're going to multiply top and bottom by 8. And so that would give me negative 40/16 plus the 49/16, which is 9/16. Okay, we're ready for the square root property. So x minus 7/4 equals the square root of 9/16. And then we can square root the top and square root the bottom, which would give us 3/4. Move the 7/4 to the other side and write it in front. And then now we can break it into our cases. 7/4 plus 3/4, or 7/4 minus 3/4. In this case, we get 10/4. In this case, we get 4/4. This simplifies to 5/2. This simplifies to 1. Okay, for this last one, we need to first move our constant to the other side and then divide everything by 3. So x squared plus 10/3 x equals 8/3. Half of b would be 10/6, which is 5/3, which makes sense. Half of 10/3 is 5/3, and square it. Gives us 25/9. Square the top, square the bottom. And so x squared plus 10/3 x plus the 25/9. And then we have the 8/3 plus the 25/9. You have to add it to both sides, keep it balanced. And then this would factor to the 5/3. And then 8/3 plus 25/9, we need to multiply top and bottom by 3 of this first fraction, which gives us 24/9 plus 25. ninths, which is 49 ninths. We're ready for the square root property. We can square root the top and square root the bottom, which gives us plus or minus 7 over 3. Move the 5/3, so it's negative 5/3. And then write your cases. Negative 5/3 plus 7/3. Negative 5/3 minus 7/3. This would be 2/3. This would be negative 12/3, which is negative 4. And so our solutions are 2/3 and negative 4.